Okay, guys, in this section 2-7, what we're looking at is how to determine whether two figures are congruent or similar. And we're talking about the 3D solids here is what we're looking at. So just to kind of review, two figures are congruent if they're the same size and the same shape. Then they would be congruent. They're similar if they have the same shape, okay, but not necessarily the same size. And remember, if two figures are similar, then we talk about them being bigger or smaller by a scale factor, which is determined by a segment or a portion of the new figure divided by the corresponding part of the old figure. And then, of course, as a reminder, here is the symbol for similar. Here's the symbol for congruent. All right. Now, we've got two rectangles here, and we're trying to determine whether they're similar. So these are 2D figures, and then we'll expand it out. Okay, so as we're looking at this, remember, if two figures are similar, then the fractions made by the corresponding parts, or the scale factor, the new over old for each one, would be the same. So like in this one, 8 matches with 4, so there's one fraction. 4 matches with 2, there's another fraction. Those both divide out to make 2. So since all the corresponding fractions are the same, we know that these two figures are similar. Now, when you're making your fractions, whether it's a 2D or a 3D figure, trying to determine if the scale factors are the same for all sides, then what you've got to do is you've got to make sure you're using the same pattern, right? And that pattern should be new over old, right? Okay, so a segment of the new figure, okay, divided by a corresponding segment of the old figure, all right? And you've got to use that same pattern to make all your fractions. You can't use new over old for one and old over new for the other one because it won't work out. Okay? All right, so let's extend it to some 3D figures. What we want to be able to do is tell if these figures are congruent, similar, or neither. If they're the same size and same shape, they're congruent. Okay? If the corresponding parts are proportional, like we had shown here, then they'll be similar. And if neither one of those two statements are true, then it would be neither. All right, so we've got two rectangular prisms that we're looking at here. Okay, we can see the dimensions of each one. I would check congruent first, okay, because if they're not all the same dimensions and the same figure, then they couldn't be congruent. So they're both prisms. All right. However, the dimensions of this one, and we'll start with from biggest to smallest, 40, 20, 8, and this goes 20, 10, 4. So they're definitely not congruent because all the corresponding parts are not the same. All right. Let's check similar though. Okay, so what we need to do is we'll write out all the matching fractions. All right. And so let's go new over old to match scale factors. So I'll start with 20 here. Okay, now here's the key. You've got to make sure that you're matching it up with the corresponding part. So I've got to figure out what 20 matches in the old figure. And remember, they're not always necessarily turned the same way. So you can't just say the front matches the front and the back matches the back and so on. Okay? So how are we going to tell which parts are corresponding? Well, 20 is the longest dimension here, right? So it's got to be matched up with the longest dimension here, which is 40. So my first fraction that I'm going to write is 20 over 40. Okay, the next fraction would be 10 over 10 matches 20, the middle to the middle. 10 over 20. Then we'll match 4 with 8. Okay, now, if all of these fractions are equal, then the two solids are similar. Okay, so what we need to do is we can tell whether these fractions are similar or the same in two ways. You can reduce the fractions and check them that way. So all three of these reduce to 1/2. Okay? Or you can divide them out and make decimals out of them and check them that way. If you do that, it's all 0.5. Okay? And so since that's the case, these three corresponding fractions are the same. We know that the answer here is similar. All right. Let's try the next one. So we've got two pyramids here. Remember, you want to try to check for congruent first. The height here is 21, the height here is 14, so they're definitely not congruent. Okay, so let's check if they are similar. So how do we check it? We have to make the corresponding fractions. All right, so we'll start with the height, which is 21. So what does the height match with over here? Matches with 14. So we'll go 21 over 14. All right. Then the sides of the base are 20, so then that would be 20 over 12. Then that remaining side should also be 20 over 12. All right. So now, as we go through and take a look at this, if we reduce these fractions down, the first one would be 3 over 2. The second one would be 5 over 3. And the last one would be 5 over 3. If we divided them out and made decimals, they would be 1.5, 1.66, 1.66. So the question is, are all of these fractions the same? And the answer is no. So they're not similar. We determined that they're not congruent. The answer here is neither. Okay. Neither congruent nor similar. Okay. All right, let's try one like this now. Okay, on this one I've got two cones here that I'm trying to determine whether they are congruent, similar, or neither. Checking the height, 6 and 9, the radius, 4 and 6. They're definitely not congruent. Let's try similar. So we'll match radius to radius, 4 over 6. Notice I'm still using new over old, so these fractions that I'm writing are the scale factor. The reason for that is because there are some problems that may ask you what is the scale factor, or use the scale factor to do this or that. New over old, that's your scale factor. Let me see here. Height, 6 and over 9 in the other one. And those are the only two dimensions we have to work with. Those would reduce down to 2/3 in each case. Or when you divided it out with the calculator, you get 0.66. And so they are the same. And so that means that these two cones are similar. All right, what about one like this? We've got two cylinders here. And so as I'm going through and taking a look at this, okay, you got to be careful when you're looking at this one. What's the radius here? It's 9. The radius here is also 9. They've given me the diameter is 18. The height is 16. The height is 16. So these are actually congruent. Why? Because the radius matches 9 and 9. The height matches 16 and 16. So don't just look at the numbers and say, oh, since the numbers are not the same, it can't be congruent. It's not necessarily true. You got to compare corresponding parts, radius to radius, not diameter. All right. And the last one that we're looking at here is two prisms. Okay, dimensions are not the same, so they are not congruent. And so let's write out our fractions. So we'll start with, let's see. What do we want to start with here? By the way, take a look at this. I know 4 matches with 8. 6 matches a missing side here, and 5 matches a missing side here. But here's what we're going to do. When we look at this, I know this is 4 and 5. Well, the Pythagorean triple is 3, 4, and 5. Okay? This one would be 6, 8, and 10. Okay? So those two Pythagorean triples you should have memorized, 3, 4, 5, 6, 8, 10. So now I can actually write 4 fractions here. So we can say that 3 matches with 6. We can say that 4 matches with 8. We can have 5 matching with 10. And 6 matching with 12. All right? Now we can take a look at our fractions. These are all reducing down to 1/2, 1/2, 1/2, 1/2, and it'd be 0.5 as a decimal. Now you don't have to check both, you just need to check one or the other. Reduce the fractions or make decimals out of it. But this is enough now for us to say that these two figures are similar. All right, and that's it.